Hello everyone, this is President Kent Fuchs. We are at a special place. We are at the bee biology unit. This is the area where Professor Jamie Ellis, who is my guest here, or I'm his guest. This is his laboratory, this is his teaching facility. And he, just a few minutes ago, gave us an amazing tour of an incredible brand new facility, which will be opening in July. But for now, we're actually where the real bees are. They don't get to move into their new facility until July.
Right.
So, Professor Ellis, thanks for hosting us here.
My pleasure. Would you like to work some hives?
Let's do it. Let's
All
try
right.
it. So we're going to go over here where real bees are.
Sure. So I'll start by describing what you're seeing here. This is a typical honeybee colony. There's probably 30 or 40,000 honeybees in this hive.
Oh my goodness.
They're coming in and out of the entrance. And so it's my job as we go into this hive to get them ready to receive us. So we do that by using a tool that people have been using for a very long time to produce smoke. And all we do is put a little bit of smoke in the entrance. The reason we do this is bees communicate with one another using pheromones. So they will produce an alarm pheromone when they get upset. So we are masking that alarm pheromone with smoke. So I'm going to take us right down into the heart of this hive, but at the very beginning, here we have a jar that we can fill with sugar water and we can feed the bees. And when I take it off, you'll see that there's plenty of worker bees here on the bottom. All of these bees are females. They're all capable of stinging, but you're protected, I'm protected, so we'll be okay.
You don't look as protected as I do.
I've been stung a few times, so it worries me a little bit less. So I'm going to smoke down in there. And this uppermost box is actually the one where the bees store the honey. So if it were honey season, all the honey in here would be harvestable for us. But before we look at that, I'd like to take you straight into the heart of this beehive. So I'm going to sit this just here.
My goodness.
And what you're seeing is a typical functioning honeybee hive. These are all, again, female bees on the top of this metal piece of equipment. This metal piece of equipment is a queen excluder. It is here to limit the queen's movement up into the honey super. So the queen is trapped below it because she's too large to fit through these wires. So she stays down here and has her babies here to ensure that there's no bees being produced where we want honey being produced.
Now that bee crawling on your hand is okay?
She has not been a problem at all. She's just been enjoying the ride, and she's even learning something here. So I'm going to take off this queen excluder. You'll see there's bees on the underside of it as well. And I'm going to rest it right here on the entrance of this hive. So the beauty of the modern beehive is it is composed of movable frames. So all of these pieces of wood are frames. You'll see that there are 10 in this hive. And when I pull one up, you'll notice that the bees have constructed comb in the frames. The bees will eat honey and they will secrete beeswax. It comes out the underside of their abdomen, and they will use that beeswax to construct the honeycomb.
Wow.
So a couple things I want to point out to you here. Most of these bees are worker bees. They're the ones who do all the work, but there are a few, like that one, and this one that are much larger. These are drone honeybees. These are the males. These are the ones who are the father of other workers potentially from other hives. And as we move these bees off of the comb, you'll notice that there's two things in this wax comb. Number one, we've got all of this glistening stuff. This is nectar that they will convert to honey. As I take my hive tool and scrape it, you'll see that nectar comes right out.
Oh, wow. So that's not honey yet?
Not honey yet. When it's honey, they will put a wax capping over the top of those cells. The thing, though, that is the most important thing on this comb is what's stored here. If you look in here, you'll notice there's a lot of orange and yellow colored doughy looking material. In fact, I'll take my hive tool, go into one of the cells and pull it out. That is pollen. Honeybees have an insatiable appetite for pollen. They will fly up to a 5-mile radius around their hive. That's 80 square miles of area that they are canvassing to collect pollen, to bring it back to their hive, to convert to more bees. The process of them collecting pollen is what gives us our fruits, vegetables, nuts, and berries. They go out, they collect blueberry pollen, the blueberry flower gets pollinated. They collect cucumber pollen, the cucumber flower, right, gets pollinated. So we get about a third of our food supply from the efforts of honeybees that are just out to collect pollen.
Pretty incredible. So how many bees roughly are in a hive again?
Yeah, maybe in this hive during peak season there'll be as many as 40,000 bees. Just on this comb there's probably 1,000 bees.
Incredible.
And all these girls are capable of stinging, but you'll notice we're not being attacked. It's a bit of a, every colony has its own mood. You get nice colonies and not nice colonies. So there you go.
I don't think I'll do that.
I'll pull out another frame or two just to show you one or two more things worth noting in this bottom box. On this comb, you'll notice that the wax here is what's covering that ripe honey.
Oh.
So that's ripe honey.
That looks delicious. I love honey.
But the wax that is here, this browner wax, is covering baby bees. So there are baby bees developing in each of those wax cells. So you can see that developing bee there.
And you can tell the difference because of the color?
Absolutely. This color here is air permeable, so you get a lot of airflow into these cells where the bees are developing. This one here is almost pure beeswax as they cover up that ripe honey.
Wow. And they're producing the honey for what reason? Is it to sustain themselves?
Great question. People have this idea that honey is bee food, but it's not. Honey is actually bee fuel. It is the energy that moves the bees. So bees store honey just so they can move. So they'll store honey during this time of year, for example, when flowers are everywhere, so that they can have enough to survive winter. It takes about this much honey for the bees to eat, to generate heat to survive winter. So honey is literally their fuel.
To produce heat.
Absolutely.
Boy. And in the state of Florida,
Yes.
what kinds of, particularly up here in this area, what kinds of flowers will they be traveling to get the pollen?
Well, that's a great question. The honeybees are generous pollinators, so they'll go to almost anything. But some of our more important crops in this region are the cucurbits, the cucumbers, the watermelons, the cantaloupes. They'll go to blueberries. The best honeys in our area come from gallberry and palmetto. Florida is probably the U.S.'s best place to produce honey. We have some of the best honeys in the world in our state. Tupelo honey, citrus honey, gallberry honey. We just have so many things for our bees to visit. Which is why the state legislature and the beekeepers and the University of Florida and others have banded together to build this new bee lab. They recognize the importance of bees and how important they are for our food supply, how important they are for our agriculture industry, and just the health of every Floridian. If you like to eat, you owe that to honeybees.
Yes. Now I've read around the country that there has been an issue with some bee colonies dying away, and some question about what the cause of that was. Is that the case in the state of Florida, and have we learned anything more about what might be the cause?
So about 10 years ago, beekeepers have started reporting elevated losses of bee colonies, somewhere in the neighborhood of about 30% a year. Florida, our losses are a little bit higher, about 35 to 40% a year, and the reason for that is we have such a warm climate, and every disease and pest that can exist on bees we have. So our beekeepers are constantly year-round having to battle these issues that our bees face. The good news is that Florida also has a growing population of managed honeybees, which is kind of a strange situation. If we're losing 30% of our bees every year, how are we growing? It's because our beekeepers are splitting colonies and they're recovering from these losses. So it's a difficult place to keep bees, but it's also an important place to keep bees. About 20% of the nation's honeybee colonies come through Florida on a yearly basis.
And what causes them to die?
There are so many things that can cause bees to die. Probably the most important killer of honeybees is the varroa mite. It is a mite that gets on the outside of the bee's body, feeds on fat bodies up under their exoskeleton, and these mites will transmit pathogens. So the mite's kind of a 1-2 punch. If you've heard of citrus greening, where the psyllid spreads the greening pathogen, varroa and the pathogens it spread is our citrus greening. They are absolutely terrible. But we also get nutritional issues. We can get pesticide kills. We can get other pathogens killing bees. We can get management issues. Bees are trucked around the country for pollinating crops. So all of these things can contribute to bee stress.
Yeah. Well, I was on a flight from Atlanta to Gainesville once, and a fellow sitting next to me was a beekeeper.
Sure.
And he said he had just shipped all of his bees out to California for almond pollination.
About 60% of the nation's managed honeybee colonies go every year to California just to pollinate almonds.
Yeah, that's amazing.
Before we close this up, let me show you one frame of honey in this uppermost box so that you can get an appreciation for honey. So these traps here are to trap out small hive beetles. That's another pest that our honeybee colonies here in Florida get. As I take out this frame, you'll see that bees are just starting to bring in some nectar. Here, that's what all of that shiny liquid is in these cells, and very soon, by the end of the honey season, this entire comb will be filled with honey and capped over with beeswax. You can even see one of the bee stressors running around there. That's the small hive beetle. That's what we're trying to trap with these traps in this hive.
Oh boy.
So bees get pathogens, they get mites, they get pesticide exposure, nutritional stress. They just have the typical issues that any agricultural livestock commodity would have.
Wow. Wow.
Which, of course, is why it was so important that the state and the university and the beekeepers banded together to augment our bee research, extension, and instruction efforts here at the University of Florida. So it's a great thing that's happening here.
Yes. And you all, this is all part of our amazing Department of Entomology and Nematology, which is ranked #1 in the entire world. And I think you all can see why that's the case. Starting with bees, but having to do with all kinds of insects and other things that are important for the economy and the well-being of our state.
Absolutely.
Yeah, wow. Pretty special, you all. Well, I'm going to go take off my suit a long ways away from here.
Sure.
And Professor Ellis, thank you so much.
My pleasure.
Yeah, this is amazing. Amazing. I look forward to coming back for the grand opening of your new bee facility.
Can't wait to show you around.
Yeah, it's special, you all. I got to go inside and see it under construction. Just incredible. With amazing design, but place where these bees are going to be living probably this later this summer, right?
In a couple of months.
Okay. Thanks again, Jamie.
My pleasure.
Take care. Thanks.
Bye now.